This is the video that I promised about from the test that we need to go over. All right, so we start with a 96.3 megahertz photon. We need to answer nanometers. So we have kind of three equations that we had related to light math, plus one that was related to the particles. So energy is equal to h nu. It treats light as a particle, energy of particles. C is equal to wavelength times nu, or frequency. But remember, nu is the same thing. This is treating light as a wave. You can combine the first equation and the second equation by using that. And then we also know that lambda is equal to h divided by mass times velocity. And notice that this is for the wavelength of a particle. This is treating a wave as a particle. This is treating light as a wave. This is combining the first two equations. Notice that this is velocity, not frequency. See the little tails up here. All right, with all that said, we need to change our megahertz into hertz so we can use so we have proper unit cancellation. So 96.3 megahertz needs to be changed to hertz. So you put a megahertz on the bottom, and then you put hertz on the top, and there are 1,000,000 hertz and 1 megahertz. So you're really looking at 9.63 times 10 to the 7th hertz. Now you want to find the wavelength, so you just use C is equal to wavelength times frequency. You know C is 3.00 times 10 to the 8th meters per second. We know that frequency, or wavelength we don't know. We know frequency is 9.63 times 10 to the 7th. I'm going to write 1 over seconds, which means the same thing as hertz, but that way you can see the units cancel out. So now you divide both sides by the 9.63 times 10 to the 7th reciprocal seconds. Now remember, we divide by the number that's with the variable. I see a lot of students making mistakes dividing by the wrong thing over here. A lot of kids will divide both sides by this number. You divide by the number that is with the variable. The proper way is to divide by the number that's with the variable. And the unit on that is 1 over s. So when you divide meters per second by 1 over s, you end up with multiplying meters per second times seconds over 1. So seconds cancel. Final answer, I just show you on the calculator here. You've got 3 times 10 to the 8th, 3 times 10 to the 8th divided by 9.63 times 10 to the 7th. So the final answer is 3.12 meters. There, a 7 got dropped off of there. There you go. That 7 there is that 7. Final answer, 3.12 meters. Oh, we want the nanometers, though, not the final answer. Oops, put that over there. So now you take your 3.12 meters, change to nanometers, meters on the bottom, nanometers on the top. So 1 times 10 to the 9th nanometers is a meter. So now it's going to be 3.12 times 10 to the 9th nanometers. That's 9 right there. Let's make that look just slightly neater, just a second. All right. Times 10 to the 9th. There you go. Nanometers. Okay. Now the next one, you want to know energy. You know energy is equal to h nu, but we don't have, oh, and there's a mistake here in case you didn't figure it out. The word kilohertz. The kilohertz should not be there. It should just say 268 meters. Okay, so 268 meters. All right, so if it's 268 meters, that's a wavelength. We're looking for energy, so we're going to have to go up and use which equation? Well, it looks like we're going to have to use this one because it has wavelength in it and it has energy in it. So change equations, go back to E equals H times C over frequency. We got 6.63 times 10 to the negative 34th. That would be joules per hertz. And the C is 3 times 10 to the 8th meters per second. And the wavelength is 268 meters. All right. Now, to do the math on that, I'm just going to multiply these numbers together. I'm going to do that on the side because I'm having trouble with my computer showing me numbers in that great a detail. It just tells me that the answer is 0. So here's the answer. I'm going to say what I'm doing. It is 6.63 times 10 to the negative 34th. Remember, I don't ever hit times 10. What do I hit? EE. So do not hit times 10. Okay, times 3 EE to the 8th. Then I'm going to divide. I get 1.989 E negative 25, which means 1.989 times 10 to the negative 25th. I'm going to divide that by 268. And that's going to give me 7.42 times 10 to the negative 28th for the final answer. Okay, so the answer is 7.42 times 10 to the negative 28th, and the answer is going to be in joules. Now we're going to learn why it's in joules right here, in case you're wondering. I'm sure you are. So you have joules per hertz. But really a joule per hertz is a joule second because a hertz is 1 over second, so I could just say it's joules divided by 1 over second, so you're going to multiply by the reciprocal. That's where you get joule seconds. So we're going to write joule seconds, and that's going to be our what's in here. Then we have meters per second. And I say what's in here is right here. That joules per hertz means joule seconds. Then we have meters per second for our other unit. And that's all divided by meters. So you see what happens to seconds, then meters, and so your final answer is in joules. Next question is related to math. You know that this is the mass question, so you're going to have to use the equation that has mass in it. That's this one up here. So we're going to do wavelength is equal to h divided by mass times velocity. Notice this is velocity, not frequency. Okay, so h is 6.63 times 10 to the negative 34th. I'm going to write joule seconds again. M is 9.11 times 10 to the negative 31st kilograms. Oh, kilograms. So what I did was change 9.11 times 10 to the negative 28th grams to kilograms by doing this. Grams here, kilograms there, 1,000. So that's that. And the velocity, it says, is 2.00 times 10 to the 8th meters per second. So now you're ready to just plug and chug and you get the final answer. Its wavelength is going to be. And once again, I'm going to do it on the side, so I'll just say what I'm doing. I'm doing 6.63 EE negative 34th. I'm multiplying that by nothing because that's on top, so just 6.63 times 10 to the negative 34th. I'm going to divide that by 9.11 EE negative 31st. Then I'm going to divide again by 2 EE to the 8th. And when I do, I get 3.64 times 10 to the negative. I have to count the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, negative 12. So that equals 3.64 times 10 to the negative 12. The unit's going to be meters. Okay, here's why. The unit is meters. A joule second is really a Newton meter second because a joule is a Newton meter. So that thing right there Newton meter, same thing. Okay, and seconds. But a Newton is a kilogram meter per second squared. Remember, force equals mass times acceleration. So I'm going to write down everything I've got on top. I've got a kilogram meter per second squared. That's a Newton. Multiplied by meters, multiplied by seconds. Times meters, times seconds. Make sure I'm not making mistakes. So joule's a Newton meter. So joule seconds will be a Newton meter second. But a Newton's a kilogram meter per second squared, so that would be all that. Meters, seconds. That's all on the top. On the bottom, I've got a kilogram. And then meters per second. So I've got on the top, I'm going to take this number here, go over here. So on the top, I've got a kilogram meter squared second over second squared. I'm going to multiply by the reciprocal of the bottom because that's how you multiply fractions. Okay, so what happens? So I got second squared here, which cancels that and that, because 2 seconds cancels second squared. Oh. There's supposed to be a meter down here. I accidentally erased. Okay, so this kilogram meter would be on the bottom, and the meter got erased. So that's why I paused there for a minute, because I noticed my units weren't going to work right. So now kilograms cancel. Now I've got meters squared over meters, so that cancels that, so all you're left with is meters. So that's why your final answer is in meters. Where did I write the final answer? Right here. So 3.64 times 10 to the negative 12 meters. That's why the unit is in meters, because everything else cancels. Okay, I'm going to stop that one, this movie, and I'll make another one for the next two problems.